All right, for our Algebra 2 chapter review, we're testing on Friday sections 2.1 through 2.4. In this, I gave you assignments from your book, and actually, as I'm looking in my book to start this, the first group is 3 through 6. It doesn't start on page 123 on number 1. It actually starts on number 3. I have to assume that your book is in front of you. I'm not going to recopy the sets of data that are there, but what I'm going to do for 3, 4, 5, and 6 is take a look at each of the situations in my textbook, and I need to decide if each relation is a function, and I have to find the domain and range. And one of the things that I find easier to do is to first identify the domain and range, and if I find that I have anything repeated in my domain, that means that there is an input that has more than one output. Then it wouldn't be a function, because the definition of a function is every input has exactly one output. When I look at number 3, in the domain, I'm going to list the x values that appear, 10, -10, 6, 5, and -6. I don't see any x values that are repeated, so I'm going to actually say right now, yes, it's a function. I can have y values, or the values of the range, repeated. Pay attention to my notation for domain and range. I'm using set notation. Now I'm just going to go grab the y values. 2, the second ordered pair also has 2. I'm not going to duplicate anything that's repeated. 2 happens twice, but I'm only going to write it down once. 2, 4, 3, and 7. Number 4, I'm going to approach the exact same way. I've got a list of ordered pairs, my domain. Let me go through the x values. I see 4, 1, 3, I see 4 again. I'm not going to repeat it, but I'm also knowing that since 4 happens twice, that this is a relation and not a function. So to address that, I have that information here. Again, 4 has 2 different x values with it. So 4, 1, 3, don't rewrite the 4. The last number of the domain would be 10. And then my range would be the y value is 5. The second y value is 5. I'm not going to repeat it. 8, 6, and 12 would be the values of my range. Number 5. Number 5 is a graph with a whole bunch of ordered pairs. The first thing that I'm going to do is see if this graph passes the vertical line test. And as I'm talking, I'm just glancing over and I see that this graph will not pass the vertical line test, because when x is -1.5, I start looking across the graph. Let me give the domain. I start looking across the graph from left to right. I see that when x is -2, I have a point above -2. Then I go and look and I see it's about -1.5, but there is 2 points at -1.5, so it's at that point where I know that this is not a function because it doesn't pass the vertical line test. Again, if you're not looking in your book, none of this is going to be making any sense. I'm on page 123. I do see that there's a point when x is -1. I keep looking. There's a point on the graph when x is +0.5, when x is 1, when x is 2, and when x is 3. So those would be the values of the domain. The range, I'm going to start looking up and down the y-axis. From the top to the bottom, the highest y value is 2.5. Then I see a point at 2, also at 1.5, at 0.5, at 0, at -0.5. Where am I? Now I'm all the way down to, there's actually 2 different points when I get down to y is -3.5. If that was a struggle for you, stop the video, go back and list all the ordered pairs for the points in the graph, and then compare that to what I did here. Number 6 is a mapping. In the mapping for number 6, I see that the domain and range are listed. This is easy money. The domain is actually listed for me. It's in the mapping, so I just have to put it into the set notation. That's 0.5 and 3. Every value in the domain has the exact same y value. This would actually be a horizontal line. The range is going to be that y value they have in common, and yes, it's a function. If I were to plot this on a coordinate plane, it would actually be a horizontal line, and that would pass the vertical line test.